Hi students, this is the third video of chapter number 10, Space Missions. Next topic is satellite launch vehicles. Satellite launch vehicles are used to place the satellites in their specific orbit. So satellite launch vehicles are used to place the satellites in their specific orbits. The function of the satellite launch vehicle is based on the Newton's third law of motion. And the function of the satellite launch vehicle is depend on Newton's third law of motion. Newton's third law of motion is to every action there is always equal and opposite reaction. The launch vehicle uses specific type of fuel. The gas produced due to combustion of the fuel expand due to its high temperature and is expelled forcefully through the nozzles at rear side of the launch vehicle. So the gas produced due to combustion of the fuel expands due to its high temperature and is expelled forcefully through the nozzles at rear side of the launch vehicle. As a reaction of this, a thrust acts on the vehicle which drives the vehicle high into the space. The structure of the launch vehicle is decided by the weight of the satellite and the type of satellite orbit. And the structure of the satellite launch vehicle is decided the weight of the satellite and the type of satellite orbit. The fuel of the vehicle also depends on these factors. The fuel forms a major portion of the total weight of the launch vehicle, and in this launch vehicle the major portion is the fuel. Thus the vehicle has to carry a large weight of the fuel with it. To overcome this problem, launch vehicles with more than one stage are used. So to overcome this problem, the satellite launch vehicle, there are more than one stage are used. Due to this, the weight of the vehicle can be reduced step by step after its launching. For example, consider a launch vehicle having two stages. For launching the vehicle, the fuel and the engine in the first stage are used. This imparts a specific velocity to the vehicle and takes into the certain height. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or an unpopulated land. Suppose there are two stages of launching vehicle. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into the sea or an unpopulated land. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. However, the vehicle now contains only one, that is the second stage. The weight now being reduced, the vehicle can move with higher speed. Almost all vehicles made up of either two or more stages. As an example, the structure of Polar Satellite Launch Vehicle, that is PSLV, developed by Indian Space Research Organization of India, is shown in figure 10.5a. So this is the structure of PSLV, that is the Polar Satellite Launch Vehicle made by an ISRO. So this is the first stage, engine using solid fuel which provides the initial thrust. This is the first stage using solid fuel. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited, and then second stage fuel is exhausted, third stage using a solid fuel, then fourth stage using a solid liquid fuel, and this is the place for satellite. So in this satellite launch vehicles, there are in this satellite, the fuel forms a major portion of the total weight of the launch vehicle. So this is the structure of PSLV made by an ISRO. The launch vehicles are costly because they can be used only once. USA, United States of America, has therefore developed space shuttle figure 10.5b, which returns to the earth except for the fuel tank and can be reused in multiple launches. Except for the fuel tank, all the parts they can reuse in multiple launches. So this is the space shuttle, separation of the booster rockets, separation of the fuel tank, and this is satellite launch in the orbit and space shuttle returns to the earth. Next one is always remember, The rocket, a type of firecracker used in Diwali, is also a sort of launcher. In this rocket, the fuel is ignited using a fuse and the rocket is projected into the sky just like a satellite launcher. Similarly, if a balloon is blown and released with its end open, the air in the balloon is forcefully ejected and the balloon is pushed into opposite direction. This can be explained using the Newton's third law of motion. So in the satellite launch vehicle, the function of the satellite launch vehicle is based on Newton's third law of motion. Next topic is space missions away from the Earth. As we have seen above, artificial satellites are being used for making our life more and more in reach. However, in the previous standard, we have learned about how the telescopes aboard artificial satellites are used to gather information about various objects in the universe. So, there are various telescopes about artificial satellites are used to gather information about various objects in the universe. For example, Hubble telescope. Similarly, some space missions are used to gain further knowledge about the universe. In this mission, spacecrafts are sent to nearby objects in the solar system to observe them more closely. New information has been obtained such missions and it is helping us to understand the creation and evolution of our solar system. For such mission, the spacecraft must escape the Earth's gravitational force to travel into the outer space. And for this space mission, spacecrafts must escape the Earth's gravitational field. To achieve this, the initial velocity of the moving object must be greater than the escape velocity of the Earth, as we have learned in the chapter 1, gravity. So in the chapter 1, we are basically studied about the escape velocity. Escape velocity of a planet can be obtained using following formula. This formula we are studied in the chapter number 1. You can just refer the chapter number 1 on page number 14. So formula of escape velocity is V escape is equal to under root 2 gm upon r. G is gravitational constant, m is mass of the planet, r is radius of the planet, and the values of this gravitational constant, mass of the planet and the radius of the planet. By solving this, the answer is 11.18 into 10 raised to 3 meter per second. So this is the meter per second, but how to if we convert this into the kilometer, so it is 11.18 kilometer per second. Thus, if a spacecraft is to escape the Earth gravitational force to travel to outer space, it must have minimum velocity of 11.2 kilometer per second. So the spacecraft have the escape the Earth gravitational field or the Earth gravitational force to travel the outer space. The minimum velocity is required, that is the 11.2 kilometer per second. Do you know the astronomical object closest to us is the moon? Light takes 1 second to reach from the moon to the Earth. It means that if we travel with the speed of light, it will take 1 second to reach the moon. However, since a spacecraft travels at much smaller speed, it takes longer time to reach the moon. The shortest time taken by G spacecraft to reach the moon so far is 8 hours and 36 minutes. Next topic is moon missions. Since the moon is the closest astronomical object to us, the first space mission to objects in the solar system were the missions to the moon. Such missions have so far been executed by USA, Soviet Union, European countries, China, Japan and India. The spacecrafts in the Luna series sent by Soviet Union reached near the moon. Luna 2 launched in 1959 was first such craft. After that, till 1975, 15 spacecraft made chemical analysis of the moon and also measured its gravity, density and radiation. So Luna 2 launched in 1959 was the first such craft. After that, till 1975, 15 spacecraft made chemical analysis of the moon and also measured the gravity, density and radiation of the moon. Last 4 crafts even landed on the moon and brought the samples of stones on the moon for analysis in the laboratories. All these missions were unmanned. So all these moon's missions were unmanned. Unmanned means without people aboard. Hence the operation is done by automatic or remote control. America also executed moon missions from 1962 to 1972. The specialty of this mission was that some of these were manned missions. So America has also executed the moon missions from 1962 to 1972, and the specialty of these moon missions is some of these missions were manned mission. Manned mission means carrying or performed by human being. In July 1969, Neil Armstrong became the first human to step on the moon. In 2008, Indian Space Research Organization ISRO successfully launched Chandrayaan-1 and placed it into an orbit around the moon. It sent useful information to Earth for about a year. The most important discovery made during the mission was the presence of water on the moon surface. India was the first country to discover this, and India is the first country to discover this. The water is present on the moon. Next topic is Mars mission. Next to the moon, the astronomical object nearest to the Earth is Mars. Okay, after the moon, the Mars is closest to the or nearest to the Earth. Many nations sent spacecraft to the Mars. Mars mission is difficult and almost half the missions were unsuccessful. The Mars mission is difficult and almost the half missions were unsuccessful. However, ISRO's performance in this mission is remarkable, and as all must be proud of it. The spacecraft Mangalyaan, made by ISRO using minimum expenses, was launched in November 2013 and was placed into orbit around the Mars in September 2014. It obtained very useful information about the surface of the Mars and the atmosphere around it. And the spacecraft Mangalyaan, made by an ISRO using minimal expenses, was launched in November 2013 and is placed into an orbit around the Mars in September 2014. And this Mangalyaan, it obtained very useful information about the surface of the Mars and the atmosphere around it. So here there are information of the some information of the Indian astronauts. Rakesh Sharma was the first Indian to travel to space. He went into space along with 2 Russian astronauts under the joint Indo-USSR space program. He stayed in space for 8 days. Second one is Kalpana Chawla. Kalpana Chawla obtained her engineering aeronautics degree from Punjab and in 1988 obtained her doctorate from University of Colorado. She was in space for 336 hours during research mission. While returning to the Earth from space on 1st February 2003, the Columbia spacecraft exploded and Kalpana perished. Sunita Williams traveled to the International Space Station in Space Shuttle Discovery in 2006. She worked for 29 hours outside the space station. She created a record by staying for 192 days in space. Next topic is missions to other planets. Many missions have been executed to study other planets also. So there are many missions are organized or executed to study other planets also. In some of these missions, in spacecrafts orbit the planet. Some landed on the planets and some just passed near the planet and observed them. So in all these missions, the spacecraft orbit the planets. Some landed on the planets and some just passed near the planet and observed them. Additionally, spacecraft have been sent to observe asteroids and comets, and they have successfully collected some dust and stones from the asteroids and brought them back on the Earth. We are getting very useful information for all these missions, clarifying our concepts about the origin and evolution of the solar system. And this information are very useful to clarifying our concept about the origin and evolution of the solar system. Next topic is India and space technology. India also had made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed to put satellites having weight up to 2500 kg into all types of orbits. So India has also remarkable progress in the science and technology of launch vehicles. PSLV, that is the Polar Satellite Launch Vehicle, and GSLV, Geosynchronous Satellite Launch Vehicle, are two important launchers. The scientific and technological feats achieved by India in the field have a significant contribution to the national and social development. INSAT and GSAT satellite series is actively working in the field of telecommunication, television broadcasting and meteorological services. Availability of television, telephone and internet services all over the nation has been possible due to these satellites only. EduSat satellite in this series is used especially in the field of education. IRS satellite series is working for monitoring and management of natural resources and disaster management. IRS satellite series is working for monitoring and management of natural resources and disaster management. IRS means Indian Remote Sensing Satellite. To exactly locate the position of any place on the Earth's surface in terms of its precise latitude and longitude, the IRNSS satellite series had been established. The full form of IRNSS is Indian Regional Navigation Satellite System. So this is the India and space technology. Read about satellite launch centers, space Thumba, Thiruvananthapuram, Sriharikota, Chandipur, Odisha. Space Research Organizations, Vikram Sarabhai Space Center, Thiruvananthapuram, Satish Dhawan Space Research Center, Sriharikota, Space Application Center, Ahmedabad. Introduction to Scientist. Vikram Sarabhai is considered as the father of Indian space program. So Vikram Sarabhai is the father of the Indian space program. His efforts led to foundation of Physical Research Laboratory PRL at Ahmedabad in 1962. Indian government is constituted Indian National Committee for Space Research under his chairmanship. And first satellite launcher center was established at Thumba in 1963. The launching of India's first satellite Aryabhatta into the space was the result of his efforts, and the launching of India's first satellites Aryabhatta into the space was the result of Vikram Sarabhai's efforts. He played an important role in the establishment of Indian Space Research Organization, ISRO. The last topic of this chapter number 10, space mission, space debris and its management. Debris means pieces for something that has been destroyed. In addition to artificial satellites, some other objects are also revolving around the Earth. Not only the artificial satellites are revolving on the Earth, there are some objects are also revolving around the Earth. It includes non-functional satellites, parts of the launcher detached during the launching, and debris generated due to the collision of satellite with other satellite or any other object in the space. And it includes the non-functional satellites, parts of the launcher detached during the launching, and debris generated. Debris means pieces from something that has been destroyed. According to one estimation made in 2016, there are about 2 crore pieces of length more than 1 centimeter revolving around the Earth. All this is nothing but the debris in the space. This debris can be harmful to the artificial satellites, and all the debris is very harmful to the artificial satellites. It can collide with these satellites or spacecraft and damage them. This debris is increasing day by day. Soon it will be difficult to launch new spacecrafts. It is therefore very essential to manage the debris. Some studies and experiments are being done with this in view. Hope that soon we will have a solution for this problem and the future satellites and spacecraft will not be in a danger anymore. So in this way we have to complete the chapter number 10, space mission. So in this chapter number 10, space mission, we are basically study about the space mission, then need and importance of space mission, artificial satellite, types of artificial satellite, their functions and the names of Indian satellite series and their launch vehicles. Then we are studied about the orbits of artificial satellites. The orbits of satellite are classified as below: high Earth orbit, medium Earth orbit, low Earth orbit. Then next we are studied about the satellite launch vehicles. Then next, space mission away from the Earth, and we are studied about the moon missions, Mars mission, missions to the other planets, India and space technology, and space debris and its management. If you have any doubt, you can ask me anytime. Thank you.